Right now, while you're watching this video, a beam of radiation traveling at the speed of light could be headed toward Earth. You wouldn't see it coming. You wouldn't feel it. One moment you're living a normal Tuesday afternoon, and then the sky catches fire. This isn't science fiction. This is a gamma-ray burst, the universe's sniper rifle, aimed at random targets across the cosmos. And right now, you are sitting in the middle of the firing range. Imagine it's a Tuesday afternoon. You're at work, scrolling through your phone during lunch. Maybe you're complaining about traffic. Maybe you're planning dinner. Normal day, normal life. Then, without warning, the sky changes color. You look up. It's not quite right. The blue is shifting to purple. People around you notice too. Some are pointing. Some are filming. No one understands what's happening yet. Within 60 seconds, your body starts absorbing lethal doses of radiation. The invisible kind that shreds DNA like it's paper. Everyone on the daylight side of Earth is experiencing this at the same moment. Billions of people, all looking up at a sky that's killing them. And here's the thing that makes this truly terrifying. This all happened because a star you've never heard of, in a galaxy whose name you couldn't pronounce, exploded 8,000 years ago. The beam has been traveling toward Earth since before humans invented writing, and you never saw it coming. For most of human history, we were blissfully unaware that these cosmic snipers even existed. We looked at the stars and saw peace, but we were just missing the right eyes to see the violence. Maybe that's why we haven't found life elsewhere in the galaxy yet. Maybe the sniper got to them first. In fact, we didn't even know these things existed until 1967, and we discovered them completely by accident. During the Cold War, the United States launched spy satellites called Vela. Their job? Detect Soviet nuclear tests from space by looking for gamma-ray signatures. On July 2nd, 1967, one of these satellites picked up a massive burst of gamma radiation. The military panicked. Had the Soviets just detonated a nuke in space? But the signature was wrong. The burst came from deep space, not from Earth, not from the moon, from somewhere out in the cosmos. And it kept happening, multiple times per month. These bursts were coming from random directions in the sky, and we had no idea what was causing them. It took decades for our technology to catch up to our curiosity. We eventually realized we weren't looking at a secret war here on Earth, but a violent birth in the deep reaches of the stars. So, what is a gamma-ray burst? Think of it as the universe's sniper rifle. When certain massive stars die, stars dozens of times bigger than our sun, they don't just fade away quietly. They collapse. The core implodes so violently that it fires two jets of pure energy from the star's poles. These jets move at 99.9% the speed of light. They're focused, narrow, like a laser beam cutting through the darkness. The energy released in just 10 seconds is more than our sun will produce in its entire 10 billion year lifetime. More energy than 1 million suns. Compressed into a beam, aimed at random into the universe. If we could somehow capture all that energy, we could power human civilization for trillions of years. But we can't, because if it's pointed at us, we're already dead. Now let me explain why we're completely helpless. Gamma rays travel at the speed of light. This isn't just fast. This is the cosmic speed limit. Nothing in the universe moves faster. So when a gamma ray burst is aimed at Earth, the light that would warn us travels at the same speed as the gamma rays themselves. There's no advance notice, no time to prepare. The warning and the weapon arrive together. By definition, you cannot see something coming at the speed of light. The information that says danger is coming arrives at the exact moment the danger does. This isn't a flaw in our technology. It's a law of physics. Even if we had 1,000 years to prepare, even if every human worked together, we still wouldn't see it coming, because by the time we detected it, it would already be here. And it gets worse. Gamma-ray bursts happen regularly. NASA's Fermi telescope detects them about once per day. Somewhere in the universe, a star is collapsing and firing these beams into the darkness. Most are billions of light years away, so far that their beams have spread out and weakened by the time they reach us. Those are harmless. But not all stars are far away, and not all jets are pointed in safe directions. For decades, we didn't know where these bursts were coming from. We just knew they existed. Somewhere out there, stars were exploding, and we were blind. Astronomers finally pinpointed one, a galaxy 8 billion light years away. 8 billion light years. That's more than halfway across the observable universe, and we could see it clearly from Earth. An explosion so powerful that we detected it from across nearly the entire width of the known universe. Let's walk through what happens if a gamma-ray burst hits Earth. Not in abstract terms, what happens to us. The beam arrives. For the first few seconds, nothing seems different. Then the atmosphere starts reacting. Gamma rays are so energetic they rip apart air molecules. Oxygen and nitrogen atoms are torn apart. Chemical reactions that normally take years happen in seconds. The sky changes color. Purples, greens. Colors you've never seen before. If you're outside, you'd feel warmth building. Not painful yet, just wrong. Your cells are absorbing energy they were never designed to handle. DNA is shredding. Proteins are breaking down. The gamma rays last for about 10 seconds. Then they stop. But the damage has just begun. Within those 10 seconds, the ozone layer, the invisible shield that's been keeping us alive, begins to collapse. The burst only lasts 10 seconds, but it sets off a chemical chain reaction. Within weeks, the ozone layer, our invisible shield, begins to waste away. With the ozone layer gone, ultraviolet radiation from the sun pours down unfiltered. Everyone who was exposed now faces severe radiation burns. Crops begin to die. Plankton in the ocean starts dying within days. The global food supply collapses within weeks. Not because of the 10-second burst, but because of what it destroyed. The beam is about 2 to 5 degrees wide. Sounds narrow, right? At 8,000 light years away, that narrow beam is wider than our entire solar system. There's no dodging it. If it's aimed at us, we're in the blast zone. Now, here's the part that probably kept astronomers worried. A star called WR104. It's 8,000 light years away. It's massive, 25 times the mass of our sun, and it's about to die. Could be tomorrow. Could be 100,000 years from now. But in cosmic terms, it's ready to blow any second. When WR104 goes supernova, it will fire a gamma-ray burst from its poles. The question is, which way is it pointed? For years, scientists worried the poles might be aimed at us. Then, observations from Keck Observatory showed it's tilted 30 to 40 degrees off. We dodged a bullet. But WR104 isn't the only star like this. There are others within our danger zone. Stars we're still studying. Stars where we don't have observations showing they're safely pointed away. And what probably keeps astronomers up at night now? Any one of these stars could have already exploded. They're thousands of light years away. If one exploded 7,999 years ago, the beam would be traveling toward us right now, and we wouldn't know until it arrives. The bomb might already be in the mail. We just don't know which star sent it. It leads to the one question everyone asks when they realize how fragile our position really is. Can we stop it? No. Can we at least hide? Underground bunkers might buy you time, but the surface would be uninhabitable for years. The ozone layer would take decades to recover, and without it, stepping outside would mean instant radiation poisoning. I know how this sounds. Like science fiction. Like I'm exaggerating for effect. I'm not. In fact, scientists hypothesize that a gamma-ray burst may have contributed to a mass extinction on Earth about 450 million years ago. The Ordovician extinction. 70% of all species died. The evidence fits. It's happened before. It can happen again. The terrifying part isn't that we don't understand gamma-ray bursts. It's that we understand them perfectly. We know exactly what they can do. We just can't stop them. and we can't see them coming. We're just waiting, watching the stars, hoping the aim is off. If this made you existentially uncomfortable, you're in exactly the right place. Hit subscribe for more ways the cosmos could end everything. And I'll see you in the next video, assuming we make it.